Hey guys, welcome to the Pre-Calc Unit 3 review on polynomials. First thing I want to point out here, this is calculator inactive. Your exam is going to be entirely calculator inactive, so this review should give you a pretty good idea of what to expect. This first polynomial looks a little bit strange the way it's written, mainly because of this. Right? We're not used to seeing fractions, but what that really is just a value of a. I'm going to pull that out front so it's 1/9. Next, I want you to notice how that is not completely factored yet. X squared minus 4, I'm going to use difference of two perfect squares and write as x plus 2, x minus 2. That just indicates a double root. So I've got x plus 2, x minus 2 times x minus 3 squared. Or you could write that out, x minus 3 times x minus 3 if you'd like. So now I'm going to get my roots. X equals plus or minus 2 and 3, which is a double. And now my y-intercept. Remember, how you get your y-intercept is you set x equal to 0. So this is a 0, that's a 0, that's a 0. Whatever's left, that's going to be your y-intercept. So it's going to be 1/9 times 2 times negative 2 times negative 3 squared. Well, some quick mental math here. 1/9 and negative 3 squared are going to cancel. So all I'm left with is 2 times negative 2, which is negative 4. My tails. So what I need to do here is I need to figure out what that leading coefficient is going to be. It's going to be 1/9 times x times x times x squared, or 1/9 x to the 4th. So if you notice, it's positive and it's even. So positive even means both tails are up. All right, now I just need to sketch it. So I've got a negative 2. I can just use tick marks there. And I need to go out to 3. So that's sufficient for labeling the x-axis. You can put the numbers in, but those tick marks are pretty self-explanatory. For my y-intercept, I'm just going to put a tick mark down here and call it negative 4. So if you don't do the individual tick marks, which you don't need to do, just make sure you use the number to label it. So now I know my graph has to go through the root negative 2, has a y-intercept of negative 4, positive 2, and positive 3, and my tails are up. Remember what a double root does. All right, it causes your graph to bounce on that root. So depending on where you're coming from, I know right here it's going to bounce. And because my tails are up, I'm guessing it's going to do this. So let's sketch it in. All right, take your time when you sketch this. And there you go. All right, second question. Now I want to go the opposite way. I want to write the equation from the graph. So a couple things here I want to point out. Roots, my y-intercept, and tails. All right, that's going to tell us a lot about this. So first, let's list the roots. All right, so we've got negative 5, negative 2, and positive 3. And my y-intercept is negative 6. Now the easy part of this is getting the factors, I think. So y equals x plus 5, x plus 2, x minus 3. Now if I were just to stop here and put that into my calculator, I'd get a graph that kind of looks like this. It would hit these roots for sure. It would have these tails, but the y-intercept wouldn't be negative 6. It'd be much lower. So what I need to do is I need to get this value for a. Now you don't have to write this out, but I'm just kind of reminding you guys where we get it. That value of a is going to be the y-intercept divided by the product of factors. So my y-intercept is negative 6. My product of factors is going to be 5 times 2 times negative 3. Now again, quick arithmetic, notice, negative 6 and these two are going to cancel. So I'm going to end up with just 1 over 5. And that's going to go right here. Now, if you were to put this equation, this is your final answer, by the way, if you were to put this into y1 in your calculator, you would get a picture that looks almost identical. It would hit all of these roots, it would hit this y-intercept, and obviously the tails would be the same. All right, question 3, it wants me to evaluate x to the 5th minus 3x squared plus 2x minus 4 over x plus 2. So first thing I want you to know, what form your answer is going to be. It's going to be a poly, right? Because I have a polynomial divided by a polynomial. Next thing here that's a little bit tricky, if you look at your exponents, we've got 5, 2, 1, 0. So I need to fill in with a 0x to the 4th plus a 0x cubed. I'm missing 2 of them. So when I set up synthetic division, inside the box is going to be negative 2. And I'm going to have a 1, 0, 0, negative 3, 2, negative 4. All right, the synthetic division process is easy. Bring down, multiply, add, multiply, add, multiply, add, multiply, add. Numbers getting a little bit bigger, but not too bad. Negative 2 times 24 is negative 48. Combine those, and I get negative 52. So now, what do these numbers represent? These numbers right here represent coefficients of your depressed polynomial. And since I start with a 5th degree, that's going to be a cube. Sorry, a 4th. This is the remainder. All right, so let's write our answer. X to the 4th minus 2x cubed plus 4x squared minus 11x plus 24, remainder negative 52. This is an open-ended question that is totally acceptable. Or instead of this remainder, negative 52, you could do minus 52 over x plus 2. Doesn't matter to me how you write it. Next question. Given f of x equals 7x cubed minus 12x squared minus 8x plus 11, use synthetic division to evaluate f of negative 3. So again, your answer here is going to be some number, a value. So let's set up synthetic division. We're going to put 3 in the box. That's the value of x. Check your exponents. 3, 2, 1, 0. So you don't have to fill in any placeholders. We have 7, negative 12, negative 8, 11. So now we'll bring down, multiply. Let's see, add. I think that's negative 9. Positive 9, sorry. Multiply, add. 3 times 19, 38, 19, 57, and add. So for this question, when you evaluate, you are just looking for the remainder. Remember, that's the y value. That's the y value of a point on that function when x is 3. So my answer here is going to be f of 3 equals 68. And that's what you're going to circle for your answer. All right, find the quotient and remainder. So this question right here is very similar to up above. You want a poly for your answer, right? Because I have a polynomial divided by polynomial. So let's just set up synthetic division. Negative 3 goes in the box. Check your exponents. 4, 2, 1, 0. So we're missing a cube. Don't forget to put that in. I'm going to have a 1, a 0, a negative 10, negative 2, and a 4. Bring down, multiply, add, multiply, add, multiply, add, multiply, add. All right, so what's my depressed polynomial? I start with a 4th degree. I depressed it 1 degree, so this is going to be a cube. That's going to be squared. That's an x. That's my constant, and that's my remainder. X cubed minus 3x squared minus x plus 1, remainder 1. Again, some of you might like to do this. You don't have to, but you could replace that with 1 over x plus 3. you replace that remainder. Question 6. Use the graph below to answer all questions. Write answers in set notation. So just a reminder, set notation is using the inequalities. Part A, where does the minimum occur? Where, if you remember, is an x value. So we need to find the minimum on this graph, which is obviously going to be right here. All right, that x value is 0. So that's where the minimum occurs. X equals 0. Now it says, what is the maximum? What is the y value? So you have to find the maximum. Now this is a relative max. That looks like it's 9, but the maximum is right here, is 10. So that'd be y equals 10. Okay, we got to scroll a little bit here. Name the zeros. Remember, another word for zeros would be roots. So you just want to find all the x values of the roots. So it'll be those 4 right there. That's going to be x equals -8, -2, 2, and 6. And if you wanted to mention that 6 is a double, that would be cool, but it's not necessary. You just have to name the roots. It's not asking whether they're doubles or triples. Next, name the relative maximums. Relative maximums, remember, are hilltops. So it's going to be something like this. There are only 2. Here's a hilltop. Here's a hilltop. This is not. Even though this is the maximum, it's not a relative max because it doesn't have a hilltop. We can't see what's going on to the right of that point. So I'm just going to name these 2 right here. What do we have? -5, 9. And the other one looks like it's 4, 5. And lastly, where is f of x less than 0? So if I'm talking about a number line, I'm talking about negatives, but graphically, that's below the x-axis. And notice it's just less than, it's not or equal to. So I'm looking for this piece of the graph right here. That's the only piece that's below. I don't want any of the other roots, any part that's on the x-axis, just below it. So that interval is going to be from -2 to 2, not inclusive. So -2 is less than x is less than 2. Given this polynomial, p of x, find p of -2 synthetically. So it specifically tells you to use synthetic division here, not just plug in. So to set that up, I would put a -2 in the box. And notice your exponents, 5, 3, 2, 1, 0. So this is missing an x to the 4th. So don't forget to put that in your synthetic division. All right, so I have 4, 0, -7, 3, -4, 9, and this process should be pretty straightforward by now. Bring down, multiply, add, multiply, add, multiply, add, multiply, add, multiply, and what's that give me? -40. Oh, nope, sorry. That was a mistake. Looking ahead here. -2 times 26 is -52. The remainder is a -43. To answer the question, you're going to write p of -2 equals -43. Question 8. Notice list. It doesn't say find, it just says list. So please make sure you don't do anything more. List only. So what I want to get a visual is I list all the factors of 10 in the numerator. So 1, 2, 5, 10. And then my denominator, all the factors of 4. 1, 2, 4. This is not going to be accepted as a solution because I didn't list them out. So I just need to list all the factors I can create with these. All right, so I'll start with my integers. 1, 2, 5, 10. and I don't really care what order you do this, but I'll probably use the 2 next. 1 over 2, 1 over 4. I wouldn't list, 2 over 2 is 1, so I don't need to list that again. 5 over 2. 10 over 2 is 5, so I don't need to list that again. So let's go through there. 1 over 2, 5 over 2. Then let's use the 4. 1 over 4. 2 over 4 is 1/2, but I've already listed it. 5 over 4. 10 over 4 is 5/2. I've already listed it, so I don't need to list that again. So 1/4 and 5/4. And that's it. Done. Once you've listed them all, you're done. Question number 9, find all the roots. So again, what I'm going to do here first is just think of the possible roots, right? Would I guess a 3? No, it's going to be plus or minus factors of the last term over factors of the first. So we don't have a lot of choice here. It could be plus or minus 1 or 2 or 1/2. So let's set up our synthetic division. Take a quick look at your exponents, 3, 2, 1, 0. So I don't need to fill in any placeholders. 2, -5, 1, 2. What I would do first is do that David-Lytle theorem. All of those would add to a 5, -5. So if I were to add all of these, that gives me 0. If 0 is the sum of all the coefficients, then you know 1 is a root. So right away I know this is going to work. I just need to get the depressed polynomial. So bring down, multiply, add, multiply, add, multiply, add. Find all the roots. Well, I just found 1. X equals 1. What I'm left with now is a depressed quadratic. 2x squared minus 3x minus 2 equals 0. I'm hoping this factors. If it doesn't, I have to use quadratic formula, but I think it does. 2x and x, signs are different. Factors that multiply to 2, it's going to be 1 and 2. Let's just double check. This here gives me a 4x. That gives me a 1x. So as long as I subtract this and get a negative 4x, that will work. So now my other 2 roots are going to be x equals 2 and x equals -1/2. The question just said find the 3 roots. I don't have to write it in factored form. I don't have to sketch a graph. I'm done. Moving on to the next question. So again, this one says use the root theorems to find a rational root. State the depressed polynomial obtained. So I have to formally go ahead and state that. Find the remaining irrational roots. This is kind of like a red flag to me. I either have to complete the square or use that quadratic formula. Okay, so let's list our possible roots here. Plus or minus factors of 6. 1, 2, 3, 6 over factors of 2, 1, 2. A lot of options. Let's see here. 3, 2, 1, 0. So I don't need any placeholders. 2, -8, 4, 6. What do I get if I add these together? That's a -6. Well, that would give me 0, but I have this 4 left over. So I know 1 does not work. I would probably guess -1 next. It might not work, but I like to stick with the smaller numbers first. So bring down, multiply, add, multiply, add. I can see now this is not going to work. And add, what's that, -8? But what do you notice? Now, you don't have to formally state this, but it's going to help us guess. Use the root theorems. Would you guess now a -2? How about a -3? How about a -6? Well, notice what we have. I chose a negative number, and my signs alternate. So again, it doesn't say specifically state the theorem, but I know that's a lower bound. So my next guess is not going to be lower than -1. I know 1 is not a root. So sometimes what I like to do is rule things out. So maybe over here, I say, well, x does not equal 1, does not equal negative 1. Let's go on and try 2. Or better yet, let's try 3. I'm kind of cheating because I know what the answer is. So if I tried 2, it wouldn't work. I would obviously move on to 3, but I'm going to save us a little bit of time here. So go back to the original coefficients, bring down, multiply, add, multiply, add, multiply, add. Okay, so I just found a root. X equals 3. There's my rational root. Part B, state the depressed polynomial. So I started with a cubic, now I have a quadratic. 2x squared minus 2x minus 2. Find the remaining irrational roots. Well, as long as it doesn't say state the polynomial in factored form, what I can do here is I can divide off a 2, make this a little bit easier to work with. X squared minus x minus 1 equals 0. This is not a good candidate for completing the square, so I have to use quadratic formula. And let's do that. C, find the remaining roots. X equals the opposite of b, 1, plus or minus square root b squared, which is 1, minus 4 times a times c, all over 2 times a. All right, so now I get x equals 1 plus or minus. Notice what happens here. These two negatives cancel out, so it ends up being addition. It's 1 plus 4. That's going to give me a 5 under the radical over 2. And that's simplified, right? I can't simplify that radical. I can't simplify the same factor into all 3 of these. So I'm done. You can circle that, and there are your other 2 irrational roots. In question 11, it says use p of x, which is a 4th degree polynomial, to demonstrate both the upper and lower bound theorems. Be sure to fully explain why. It's going to be a bit of work here. First thing I'm going to do is I'm going to list the possible roots. Plus or minus factors of 48. Wow, there's a lot of them. 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. And then don't forget, you have all these odd numbers that you can divide by 2. So that gives me 1/2, 3/2, and that's it. All right, so I have to demonstrate an upper bound and a lower bound. To demonstrate an upper bound, I have to choose a positive number, and all the sums have to be positive. So if I choose one that's too small, my sums aren't going to be positive. So I'm going to guess 6. The bigger the number, the more likely it is that it's an upper bound, but also the bigger the numbers are going to be that you have to calculate without a calculator. So let's check our exponents. 4, 3, 2, 1, 0. I don't need to fill in with any placeholders. So I've got 2, 4, negative 26, negative 76, and negative 48. Bring down, multiply, add, multiply. Wow, 6 times 16. Well, 6 times 10 is 60. 6 times 6 is 36. 60 and 36, 96. So this is going to give me 70. That worked out okay. 6 times 70 is 420. Minus 76. Well, 420 minus 70 is 350. Subtract another 6, 344. This one might get a little crazy. You might have to, over on the side, work this out. 6 times 300 is 1,800. 6 times 40 is 240. And 6 times 4 is 24. So you can take 1,800 plus 240 plus 24. That gives you 216. And then I have to subtract 48. That gives me 2,000. Oh, no, sorry. I was looking at the wrong number. This gives me 2,064. This gives me 2,016. Now, if it's really obvious here that that's going to give you a positive, I don't care if you actually calculate this, or you could do something like this and then just show me that's positive, because you're just trying to demonstrate the theorem. So the theorem is choose a positive number, and all of these sums are positive along the way. So now you just have to explain it. Okay, 6 is an upper bound because, number one, it is positive and all the sums are positive. So that means there's not going to be any roots greater than 6. So now lower bound. Well, I got to start with a negative number. Let's pick negative 6. Start over. 2, 4, negative 26, negative 76, negative 48. Bring down, multiply, add, multiply. Let's see, negative 26 and 48, that's 22, I believe. Multiply, so again, 6 times 20 is 120, 6 times 2 is 12. So add those together, you get negative 132. Add, well, 70 and 130 is 200, and then you've got an additional 8, so that's going to be negative 208. So again, right here, let me just show you, this isn't actually that bad to multiply. 6 times 200 is going to be 1200, 6 times 8 is going to be 48, so it's going to be 1248. But let's say you didn't want to do that. But it's obvious that negative 6 times negative 28 is going to be way more than 48. So I'm fine to just do something like this and then indicate here, I don't know what that number is. I don't care what that number is, but I know it's going to be positive. So now you can demonstrate the lower bound theorem. Why? Because you picked a negative number here and your signs alternate. So negative 6 is a lower bound because it is negative and the sums alternate signs. So you're not going to need to recite these theorems, but you need to be able to replicate them. Show us what the syntactic division is going to look like, and then explain why it is an upper bound or lower bound, or why it describes the locator theorem. All right, so this question right here is going to be like the big question. I'm going to give you a 4th degree polynomial. You have to find all the roots and you have to graph it without a calculator. So, how do I like to start? List the possible roots. All right, so it kind of narrows your guesses, if you will. So plus or minus factors of 10. 1, 2, 5, 10. Not bad at all. So I'm going to start with syntactic division. I'm going to make sure my exponents decrease by 1 each time, and they do. So I can fill in here with 1, negative 5, negative 3, 13, and 10. So before I choose a number that goes in here, I like to check the Lytle theorem. What happens if I were to add all of these numbers up? Does that equal 0? Question mark. No. So that means 1 is not going to be a root. And if you want to eliminate it up here, just so you remember, don't test it, that's fine, or just remember it. So if 1 doesn't work, I usually go to negative 1. I don't know if it works or not, but it's a smaller number to test. So bring down, multiply, add, multiply, add, multiply, add, and I got lucky, it worked. So what do we know? X equals negative 1 is a root. So now I'm using the depressed polynomial. I'm not going to go back and use these again. Don't start all over. Once you find one, basically what we're doing is we're tapering down to a quadratic. So now I'm just going to use these, setting up syntactic division again. So I know I'm not going to use 1. It's still not going to work, but negative 1 might. All right, you can go on, maybe try 2, try negative 2, but don't forget you could have a double root. You could have a triple root. So I'm going to try negative 1 again, just because it's so easy and fast to try in syntactic division. Bring down, multiply, add, multiply, add, multiply, add. It worked. All right, so x equals negative 1. It's a double root. You can write it out twice. You can write double next to it. Doesn't matter to me. So now what we have is a depressed quadratic. This is going to be x squared minus 7x plus 10. So what I need to do now is I need to set that equal to 0 and solve. So that's going to be x minus 2, x minus 5. That's going to give me 2 additional roots, x equals 2 and x equals 5. Now, I know the question didn't ask you to do this, but what you might have to do on the exam is write the original p of x in factored form. So I'm going to do that right now. P of x equals, well, it'll include these factors. All right, 'cause I didn't divide off any numbers, so it's going to be x minus 2 times x minus 5. And then don't forget I've got this double root here. So that factor will be x plus 1. I'm going to square it. Or you could write it out twice, doesn't matter. So again, I know the question didn't ask for it, but you might see that on the exam. And then lastly, I need to graph. So here are my roots. All right, got my roots. I need the y-intercept. Easy. It's going to be 10. I need my tails. Easy. It's a positive 4th degree. So tails are both up. Now I'll try and sketch it right here so you guys can see. It's going to be a little bit small. Okay, so roots, I've got -1 out to 5. So there's -1, 1, 2, 3, 4, 5. My y-intercept is 10, so I'll just put one tick mark up here and label that 10. And my tails are both up. So let's see. There's a root. Goes through the y-intercept. Goes through 2 and 5. And my tails do this. Don't forget that that is a double. Your -1 is a double. So that means it's got to turn around, which makes sense, right? It's got to go back up through here, come down through, and do that. That's what it's going to look like. So it comes down, turns around, goes up, pass through, turn around, pass through, join that tail. Excellent. So there's a good sketch of that polynomial. Our last question. I know here it says calculator active, but on the exam it's going to be inactive. And this is going to be given to you. So you're not going to need to use your calculator to put in a y1 and spend all that time narrowing the window, finding relative maxes, relative mins, and all these coordinates. It's too time consuming. So notice what this says. There's the function. It's already graphed for you, so you don't have to worry about that. You don't have to worry about this. Just notice it's finite, so it's got these endpoints. Find the following right answers in interval notation. All right, so that might make it a little bit easier for us. First of all, what is the range? So for range, what I'm looking for is the maximum y and the minimum y, because that is range. And don't forget, it's a y value. So I'm going to start by saying y is an element of bracket. The lowest y value goes first. So that's going to be -91.7, comma. The maximum is 1720. And it includes that, so that's going to be a bracket. Where is an x value? So you have to look at these. Here's the lowest one. Where is that going to be? I want that x value. Well, that's going to be 3.7. So I'm going to say x equals 3.7. What is the maximum? Maximum, what is that? That's going to be a y value. Well, it's this. That's 1720 is the maximum. Y equals 1720. Name all relative minimums, only the minimums. Those are valleys. So here's one, and here's one. I've got two valleys. So I'm looking at -0.7, comma, -8.8, and 3.7, comma, -91.7. Give all the roots. So the roots are going to be where it crosses the x-axis. No, there's only two of them. Remember, root is an x equals. It's not a coordinate. So x equals -1.5, comma, 5.1. Okay, next. Where is f of x greater than 0? So remember, graphically, that means above the x-axis. Well, I've got a couple intervals, and this one gets a little tricky because notice this does not say or equal to. So that means open circle here. There's above, but that's a closed circle. So I need to represent that interval first. Okay, how do I do that? X is an element of bracket, -3, comma, negative 1.5 parentheses, because this bracket represents the closed circle there, parentheses represents the open circle there, and then in between those. And now I'm going to have something similar over here. That's going to be open, and then I want this whole piece in, and that's going to be closed. All right, so I'm going to have 5.1 to 8 with parentheses here and a bracket here. So union, parentheses, 5.1, comma, 8 with a bracket. And finally, where is it decreasing? X is an element of. Decreasing means going downhill. So if you look at the graph, I'm decreasing here. We never use endpoints for increasing or decreasing. So I'm decreasing there, and I'm decreasing here. And that's it, those two intervals. All right, so I got from negative 3 to negative 0.7, and then from 0 to 3.7, parentheses for all of those. Negative 3, comma, negative 0.7, union 0 to 3.7, parentheses for all of those. Okay, so guys, I hope this helped. I hope you're able to maybe fix any mistakes you might have had, and it prepared you a little bit better for our upcoming unit exam. As usual, if you have any questions, don't hesitate to reach out and ask. Thanks for watching.